STP review, that's so Unit 1. Actually, it is. STP, that's standard temperature and pressure, which is from our gases unit. So I'm already remember standard temperature is 273 K or 0 degrees C, and pressure is 1 atm. And then there's like 15 other things. You know, it could be like 760 torr and psi and all these other ones too. All right, so what's this say? Moles can be related to liters, that's L, of gas. This is volume. Right, it's liters of gas at standard temperature and pressure. So there's our STP. When a sample of gas is at standard temperature and pressure, there are 22.4 liters for every 1 mole. Okay, so 22.4 liters for every 1 mole of gas. This can be used as a conversion factor. So that means numerator, denominator. Okay. Examples. How many liters, so we're looking for liters, does a container occupy if it holds 3 moles of argon gas at 273 K and 1 atm? So 273 K, 1 atm, that's STP. So that means I can use this 22.4 liters. So I put moles on the bottom, cancel it out. 3 times 22.4 liters, 67.2 liters of argon. Because it's at STP, 3 times 22.4. Okie doke. Number 2. If a 10-liter canister, so it's giving us 10 liters, it at STP, so that means I can use my 22.4 liters. How many moles, so looking for moles, of hydrogen are in the canister? So I have 10 liters of hydrogen. So I need to get rid of liters, so liters goes on bottom, moles goes on top, 22.4 on the bottom, divide it. Man, they must have used a calculator, because I wouldn't be able to do that. Well, I mean, you could do long division, I guess. Maybe they did long division. Okay, so 0.45 moles of H2. Alright. So pause the video, write a couple observations, be ready to discuss. I'll be looking for them in class. Don't be that person. Be better than that person. Okay, so you wrote some observations. Let's move on and talk about molecule-atom conversions. So the STP was review. Now let's keep reading. The subscripts, okay, I know subscript is like the number below the letter. In a chemical formula, indicate the number of atoms in 1 unit of the chemical. So unit being ionic particle or molecule. Therefore, these subscripts can be used to relate the number of atoms. So number of atoms, so subscripts is number of atoms of each element in a chemical. So relate the number of atoms, so to each other, I'm assuming. Since a mole is just a certain number of atoms, subscripts can also be used to relate moles together inside of a compound. Right? So they relate number of atoms. Moles is just a number of atoms, so you can also use moles. Alright, so we got a little chemical formula here. Hydrogen, oxygen, making water. Number 1, if 5 molecules of hydrogen, so that's H2, react with oxygen, how many atoms, so atoms would just be H, are reacting? So we have 5 molecules, so we want to get molecules on bottom, atoms on top. Well, in 1 molecule of H2, right, the subscript is 2, there are 2 atoms of H. So molecules cancels, we get 5 times 2, 10 atoms. All right, because each molecule has 10. It's like you got 5 pairs of shoes, that's 10 shoes, because there's 2 each, right? That's what the subscript's saying. How many moles of water, so now we're looking for moles of water, could be produced from 20 moles of hydrogen atoms, assuming there was sufficient oxygen available? So notice they say hydrogen atoms, right? So that's 20 moles of H, not H2. So we put moles of H on the bottom, and then we know that in 1 mole of H2O, right, the subscript tells us there would be 2 moles of H. So 20 divided by 2 gives us 10 moles of H2O. Number 3, if a certain sample of water contains 17 atoms of oxygen, how many water molecules are there? Okay, so 17 atoms of oxygen, we put atoms of oxygen on the bottom. Well, the subscript for water is just 1 for O, so it's a 1-to-1 ratio. So this one's the easiest math ever, right? Because however many atoms of oxygen you have, that must be how many water molecules there are, right? Assuming it's pure H2O and there's no other oxygen, compounds in there. Okay, so again, make some observations. Be ready to discuss. I'll see you in class. Looking forward to it. I know you are.